Welcome to our competency-based question series designed chapter-wise to enhance your conceptual learning and understanding. Question 5. A coin is placed at the bottom of a beaker. The beaker is then filled with a layer of glycerine followed by a layer of water as shown in figure. When viewed normally by an observer in air, the coin appears to be at a depth of 7.9 centimeter. If the refractive index of water is 1.3, calculate the refractive index of glycerine. So, what are the things that are given to us? Refractive index of water, that is 1.3, and total apparent depth, that is equal to 7.9 centimeter. And the total real depth is equal to 11 centimeter. So 5 centimeter water is filled, and after that 6 centimeter glycerine is filled. Now, before solving this question, let me give you the relation between the real depth and the apparent depth. The refractive index of a medium, mu, it is the ratio of real depth to apparent depth. So, if I draw a figure and this is the real depth y and the raised height is x. So, apparent depth will be y minus x. So, mu will be equal to y divided by y minus x, where y is actual depth and x is raised height or the displacement because of the material present, and y minus x is apparent depth. We can use this formula to find the raised height for the individual medium. So we can write mu times y minus x is equal to y. If I cross multiply this, and then y minus x will be equal to y by mu, and this implies if I take this x towards the right hand side and y by mu towards the left hand side, I can write x is equal to y minus y by mu. So this is the formula for raised height. Now let's try to apply this formula for the individual medium, water and glycerine. So for water, the raised height x for w, it can be written as y for w minus y for w divided by mu for w. So that is the actual depth for water minus the actual depth for water divided by the refractive index of water. So the actual depth for water is 5 centimeter. So what we can write? 5 minus 5 divided by 1.3. The refractive index of water was given in the question as 1.3. So when we solve it out, 5 minus 3.85. 5 divided by 1.3 is approximately 3.85. So the raised height for water, it is 1.15 centimeter. Now, we are having one another medium, that is glycerine. And it will also cause the coin to raise. But total raised height, it is equal to actual depth minus apparent depth. Actual depth is 11 centimeter because the beaker is being filled with water and glycerine up to a height of 11 centimeter. So that will be equal to 11 minus apparent depth. And in the question, it is given that the coin appears to be at a depth of 7.9 centimeter. This is our apparent depth. So it will give us 3.1 centimeter is the total raised height. Out of this, 1.15 centimeter is because of the presence of water. So what will be the raised height because of the presence of glycerine? That will be difference of these two. So raised height due to glycerine, that is x for G, that will be equal to 3.1 minus 1.15 centimeter. And when we solve it, it will be equal to 1.95 centimeter. Now we can apply this formula for glycerine to find out the refractive index of glycerine. So what I can write? The raised height for glycerine is equal to the actual depth of glycerine, that is y of G, minus actual depth of glycerine divided by refractive index of glycerine. So x for G, it is 1.95, and the actual depth of glycerine is 6 centimeter. Glycerine is filled up to a height of 6 centimeter. So it will be 6 minus 6 times the refractive index of glycerine. If I take this 6 by mu of G toward the left hand side and solve it, it will become 6 divided by mu of G is equal to 6 minus 1.95, and that will be 4.05. And if I cross multiply this will give me mu of G is equal to 6 divided by 4.05, that is approximately equal to 1.48. So we have obtained the refractive index of glycerine, that is 1.48, and this is the required answer. Now let's take part B of this question as well. In part B, it says if the observer slowly moves the eye away from the normal, the object suddenly disappears at a certain position. Explain this observation. So if the observer is moving away from the normal slightly like this, what will happen? That there will be an angle of incidence I which is greater than critical angle, because in both the cases the ray is moving from rarer medium to denser medium to rarer medium. Glycerine is denser, water is also denser, and air is rarer. So in both the cases, the ray is moving from denser to rarer. And there will be an angle of incidence I at which the total internal reflection will take place. And when TIR will take place, no ray will be coming out of the beaker and the coin is not visible. So what we can write? We can write as the ray travels from glycerine to air, it refracts at two surfaces, one at glycerine water and other at water air. Since both the surfaces, the ray is moving from denser media to rarer medium, for a particular angle of incidence, the ray of light will undergo TIR. And hence the coin become invisible. So this is the required answer for part B. Keep learning, keep practicing, keep excelling.